this video is going to serve as a guide to stoichiometry. It'll be one part of two. The next video will be covering the second half of stoichiometry at the 11th grade level at least. I'll split this into chapters so you know what you're getting into. You know, you can skip to the part that's going to be useful for you, whatever. And yeah. A lot of people think this unit's hard, likely because you have to keep track of exact numbers. But if you got that down, you'll be fine. As long as you watch this video, you'll be fine. So, there's not much theory involved. Like, for the theory, I suppose, go to your teacher's booklet, right? But, here's one. This is gonna take like 1 minute. Qualitative analysis. Qualitative analysis versus quantitative. Here's a really easy way to remember the difference. So, like qualitative is like, hey, I lighted a dynamite on fire and it blew up. That's qualitative. Quantitative would be like, I measured the precise amount of compounds in this dynamite to make exactly 2 million joules of energy disperse. So an easy way to remember is, do you guys know what a quant is? You likely do. A quant does a lot of math. So for quant, quant is numbers. So quantitative would involve numbers, measuring, like a quant. And qualitative, well, this food is really low quality, man. Like, you can tell there's mold on it. Well, that's qualitative. So firstly, let's cover balanced chemical reactions. Get the total ionic equation from that, then a net ionic equation. So first, let's get a chemical reaction. Let's say, what if silver nitrate So for this question, I'll give you like 10 seconds to do it, or pause the video. I'm not putting on a timer. And yeah. So, reaction between silver nitrate and aqueous strontium bromide. So, silver has a charge of 2. So, silver has a charge of 1, meaning this is going to be the formula, plus strontium, and we must add a subscript of 2 to bromide since it's -1, +2. This shall produce silver bromide plus strontium bromide, I mean nitrate, whoops. And write the states, use your solubility table, or chart. I meant solid for this one. So this is our chemical reaction, but it's not really balanced. There's 2 bromides here, and then 2 here. What I like to do is, let's balance nitrate first. That's our polyatomic ions. There's 2 here, 1 here. Let's do this. 2. So there's 2 silvers here, 1 here. Do that. 2. 2 silver, 2 silver. Okay, 2 NO3, 2 NO3. 1 strontium, 1 strontium. 2 bromide, 2 bromide. Okay, great. Now let's get the total ionic equation. Your total ionic equation is when you consider all of the ions acting within this reaction we've made. So, oh yeah, you guys cannot see I wrote aqueous here, but here we go. Anyways, so 2 times 1, so there's going to be 2 silver ions, plus 2 NO3, same logic. Write your states, it's important, very important. Plus SR, 2 plus, aqueous, plus 2 Br minus aqueous. And then arrow sign. We're on a tight budget here, so I'm running out of space. I hope this is not too aesthetically horrific. And yeah. So notice something here. This is solid. It doesn't actually break apart into ions. So you're gonna keep this as 2AgBr as a solid, okay? 2AgBr solid. Once again, we gotta make the entire thing a little bit smaller. It's fine. And then this is gonna break apart because it's aqueous. So plus SR to plus aqueous plus, let me fit this in, 2NO3 aqueous. This is our total ionic equation. Now we're going to do our net ionic equation. Essentially, what you want to do here is you want to cut out the spectator ions. What is a spectator ion? Well, it's the ion you have on both sides of the arrow. So on this side, you know, like left of the arrow and right of the arrow, okay? Consider it like, you know, if you have a left vector and a right vector, they cancel each other out, right? Maybe if you're into physics or math, or if you're like above the age of 13, that analogy helps. We can cancel out strontium because strontium's here and here. Okay, strontium gone. What else? We can cancel out nitrate as well. And there's a nitrate here, nitrate here. Forgot to write the charge for that. And now, what else can we cancel? Well, we cannot cancel bromide or silver because although silver and bromide are on two sides of the equation, this does not actually disassociate. This does not break apart. It stays as a solid. So there's no ion to cancel out because it doesn't break apart into ions. So this will stay as is, and our net ionic equation will simply be 2Ag plus 2Br minus arrow sign 2AgBr solid. Furthermore, you can simplify this a bit and just make it, because you know there's 2, 2, 2. What does that simplify to? 1. So you could just rewrite it as Ag plus Br minus AgBr solid. And remember to write every time, write your states. Reaction of magnesium metal and hydroiodic acid. Okay, so Mg, and when metals are alone, they're solid. Reacts with hydroiodic acid, Hi, which shall be aqueous because it's a strong acid. Arrow sign. This is a single replacement, so Mg and H swap places. So now you have Mg I2 plus H, and remember, H is a diatomic element, so it'll be H2 on its own in its gas state. Okay, so is this balanced? No, because there's two iodides here, one here, two hydrogens, whatever, but this is a really easy fix. Just simply 1Mg, 1Mg, 2H, 2H, 2I, 2I. Finished. Now, for TIE is slang for total ionic equation. Let's do it. So as we know, Mg is not an ion, it's a solid. Keep it as a solid. Mgs, 2 times 1, 2H plus 2I minus, write your states, AQ, arrow sign, aqueous, split it apart, Mg, 2 plus 2I minus plus H2 as a gas. Keep your gas as a gas, it's not an ion. Now let's do our net ionic equation. So we have 2I and 2I here, so we have jurisdiction to cancel them. What else is common? Well, there's hydrogen as a gas, which doesn't match with this, and there's magnesium as a solid, which doesn't match with this. So really, we just make it this, Mgs plus 2H plus aqueous, arrow sign, H2, well actually, I don't want to confuse you guys, I'll just write Mg first. Mg, 2 plus aqueous, remember, aqueous, plus H2 gas. Alright. So, we'll do one more question before moving on. Okay. So, hydrochloric acid, aka HCl, aqueous, plus potassium phosphate, K3PO4, once again aqueous, arrow sign. Okay, so H and PO4 do indeed go together. H3PO4 aqueous plus Cl and K go together. KCl. Okay, great. Now there's 3 hydrogens here and there's 1 here, so let's do ourselves a favor and fix that. Okay, now there's 3 HCl, but now there's 3 chlorides. Not an issue, just 3 chlorides. Now look, are we finished? 3K, 3K, 3H, 3H, 3Cl, 3Cl, 1PO4, 1PO4. Alright, so we're done with the balanced chemical reaction. Total ionic equation. So this is strong acid. This will dissociate. So you got 3H plus 3Cl minus, write your states. Always remember, write your states. Plus 3K plus PO4 3 minus AQ. Sorry on how bent this is, and then arrow sign. So H3PO4 is not a strong acid. It's weak. It's a weak acid. So it doesn't actually dissociate. I will have a video covering acids and bases in the future, but I'm assuming you're doing stoichiometry after the acids and bases unit. So unless your school curriculum is different, yeah, this is a weak acid. So it stays as is, but we're gonna write it as AQ because saying it's solid would be kind of wrong. We're just gonna write it as aqueous regardless. And then plus 3, oh yeah, I forgot to write this as aqueous. Plus 3K plus aqueous plus 3Cl minus aqueous. Alright, so this is really bad, but let's see, what is common? Well, chloride's common. Cancel. Cancel. K is common. Cancel. Cancel. What else? Well, these are not actually common, so our final thing we can write is 3H plus, oh, this is our net ionic equation, by the way, net ionic equation. Okay, 3 plus 3 hydrogen aqueous plus PO4 3 minus aqueous gives us a very nice weak acid. Forgot the name for this one, but who cares? That's the end of balanced chemical reactions and the such. So now we're gonna move on to the first type of stoichiometry, which is gravimetric stoichiometry. So, what is gravimetric stoichiometry? When the word gravimetric pops into mind, you might be thinking, oh my god, are we dealing with gravity? And no, we're not. But this is a real quote from him. He said, when I saw the apple fall from the tree, I wondered, how much moles is the apple if I knew its mass? That is actually a real quote. Essentially that. Gravimetric stoichiometry is when you have mass and you're trying to find out moles, or, is this mass to moles conversion? So calculate the mass of iron 3 oxide produced by the reaction of 500 grams of iron with oxygen from the air. Alright. So here's what the question states. The question is stating that iron is reacting with oxygen. Okay? So Fe as a solid because it's metal plus O, diatomic, and a gas, arrow sign, into FeO, Fe2O3. Okay, so remember, is this balanced? We have to balance it before anything happens here. No, it isn't? Well, how can we balance it? There's 2 oxygens here, 3 oxygens here. The lowest common multiple of that would be 6. So we can just do this. 2, 3. So now there's 6 oxygens and 6 oxygens. There we go. But hey, there's 4 irons. Well, okay. Everything is fine. We have now balanced it. It tells you have 500 grams of iron. So what you want to do here is you want to convert your iron to moles, okay? 500 grams of Fe multiplied by what you're trying to cancel out. So we want to cancel out grams, so we put that here. And we want to get moles, so we put that here. And you should know this, but I'll tell you if you don't. Given times 1 over given, because we know how fractions work. The same thing on numerator and on the denominator cancels out. Alright, so what is the molar mass of iron? 55. Okay, so now we can calculate the moles of iron we have. 500 divided by 55.85 gives you, keep the exact value. I want you to include every decimal. Alright, I don't want to see anything forgotten. This equals 8.952551477 moles of Fe. And always write the moles and the compound or element it's associated with, because if you don't, you're gonna get lost in the sauce. With this information, moles of iron, how can we get mass of iron oxide? Well, to get the mass of iron oxide, you need the moles of iron oxide. To get the moles of iron oxide, if you have the moles of something else in the balanced chemical reaction, you can get that. So we're gonna multiply this value in a manner that gives us what we want. So let's look at the balanced chemical reaction, right? Let's cancel out moles of iron. There's 4 moles of iron. Let's cancel that out. 4 moles of Fe. Same principle, given times 1 over given. So let's cancel out moles of iron. Boom, boom. But what do we put on top? Well, we want moles of this, so we can just put 2 moles of this. So now in your calculator, and oops, I just realized you guys cannot see what I'm seeing. So yeah, 2 moles of Fe2O3. So after this, now what your calculator should tell you is you now have, and get it exactly, 4.476275739. So once you have moles of iron oxide, tell me, how would you get the mass? And you know how. You do know how. Just multiply this by the molar ratio. So let's do the same thing, right? Moles on the bottom, cancel, grams on the top, and should be, if it's a different molar mass, it might be different depending on your data booklet, because things can change, but you should get around the same answer I'm about to get from this. So times 159.70 gives us a value of 714.8612355 grams of iron oxide. Now consider the sig digs in the question. There are 3 significant digits. This will turn this into a 5. So our final answer is 715 grams of iron oxide, obviously. Consider this question. So the first thing I want you to do is determine the actual mass of copper that's reacting, right? So our numbers are 15.42 and 14.15. Let's take the difference of those. 15.42 subtract 14.15. This gives us 1.27. Now, if the initial mass is 15.42 and the final mass is 14.15, that means that only this amount reacted. So, this is the number we're going to be using for copper. Also, assume copper to be copper 2+. I'm telling you to assume this because copper 2+ is more common than the other charge. So, yeah. So let's write the chemical reaction first. Cu as a solid is going to react with Ag and O3, which is a solution. This then produces Cu and O3, 2, aqueous. Move my camera a bit more there. Plus. Okay. So what you do here first is use your grams of copper to get the moles of copper. 1.27 G of Cu multiplied by mole on top, G on bottom, cancel. And it is 63.55. Your data booklet once again might have a slightly different number. It's okay. And write your exact value, 0.0199842. Oh wait, my handwriting is horrible. Sorry guys. 199842644 moles of copper. Okay. So yeah, now we're trying to get the mass of the silver that was produced. To get the mass of silver that was produced, we gotta get the moles of silver that was produced, and we have the moles of something else, so we can use the molar ratio to get the moles of what we want. So, what we're trying to cancel out is moles of copper. Alright. Because, this coefficient is 1. Remember, if you don't see a coefficient, assume it's 1. Cu, cancel. 2 mole of Ag does not cancel. And then, that's an arrow. Just multiply your value by 2/1. And now you have 0.0399685287 mole of silver. And yeah, just get the grams of this, which should be, if my memory is correct. Kidding, I don't have the molar mass. I don't have every molar mass memorized. That's psychotic. Plus 1. Okay. Times 107.87. And there's 4 sig digs in the. Let's see how much sig digs there are. 1, 2, 3, 4. Okay. There's 4 sig digs. So, your final answer, if I can actually write it, let's go here. Your final answer should indeed be 4.311 grams of silver. Anyways, thank you for watching, reaching the end of this video and such. I wish you good luck on your studies, chemistry and whatever other subjects you're taking, math, physics, biology, etc. If you feel like this video helped you, then subscribe. It makes a difference. And just drop a comment on whatever you need help with. I'll get a notification pretty fast, most likely. I'll reply pretty fast, I think. And yeah, if you have any questions, drop them. You want any videos you want me to make any videos, drop a comment. Hit that bell, subscribe, all of that. And yeah, part 2 will come out later. I don't know.